Hello friends, welcome to Brinda and Bitu Vlogs. Today I am going to explain you the chapter 2 physical quantities in that density. You hear the term density everywhere in your daily life. What is density? Density is a mass per unit volume of a substance. It's called as density. What is the SI unit of density? The SI unit of density is kg meter raised to minus 3 or kg per meter cube. It is the SI unit of density. Then, what is the CGS unit of density? CGS means centimeter gram second. CGS unit of density is gram centimeter raised to minus 3 or gram per centimeter cube. Let us see the relationship between kg meter raised to minus 3 and gram centimeter raised to minus 3. 1 kg meter raised to minus 3 is 1 by 1000 gram centimeter raised to minus 3. 1 gram centimeter raised to minus 3 is 1000 kg meter raised to minus 3. And we have to know what is the formula for density. Density is mass of the substance by the volume of the substance or divided by. This is when we are given the mass and when we are given the volume, we divide the mass by the volume. Now let us see how to determine the density of regular substances or regular solids. Now we have in our day-to-day life, we have many regular solids. So we are going to start with how to determine the density of regular solids. To determine the density of a regular solid, find out its mass. How to find out its mass? Mass is found out through our physical balance. So the mass is through our physical balance. Now I have a piece of duster. So this duster is a cuboid in shape. So I find out the mass by keeping it on a physical balance. Its volume. How can I find out its volume? So first we have to know which shape is this cuboid. Which shape is this duster? So it is cuboid in shape. So we have many formulas to find out the volume of a cube, cuboid, sphere, cylinder. Let me write down it. Volume of a cube is side cube. Volume of a cuboid is length into breadth into height. This is L into B into H. Then the volume of a sphere is, many of them get confused with the sphere and cylinder. The volume of the sphere is 4 by 3 pi r cube. Because now in a square, the upper surface, the lower surface and the one. Now see here. If this is a sphere, the upper surface one, the lower surface one, and in the middle there is one more. So we can remember like that as cube. For a cylinder, now I am writing for a cylinder. The volume of a cylinder will be pi r square h. Here h is height, r is a radius, and pi's value it is 22 by 7 or 3.14. So let me repeat the formulas. Volume of a cube is side cube. Volume of a cuboid is L into B into H. Volume of a sphere is 4 by 3 pi r cube. And volume of a cylinder is pi r square H. So using these formulas, we will find out the volume of any substance. Now for example, we have to use the formula L into B into H. Okay, so for this is the cuboid. Now let us go to the next topic. That is the vessels which are used to measure density or the volume. What are the vessels used? You know, commonly vessels which are used are, about a measuring cylinder. These measuring cylinders have a fixed amount of length. These are same like Mahauer test tubes, but they have little variation. Okay, and they have markings in them. So let me mark 0, 10, 20, 30, 40, 50, 60, 70, 80, 90, and this is 100. So this is how a measuring cylinder is, and you will have fixed amount of volume. So this will be the amount of volume. You have a meniscus. Meniscus is a curved. Now if you pour water into it, it won't be always flat. It won't be flat. It can't be like this. Only in some cases, but it will be in a meniscus. Okay, this is a meniscus. Okay, so I'll just tell you. So when you pour water into it, it forms a meniscus. Now let us go into the next part. After this measuring cylinders, we have our second one is measuring beaker. Let me rub this so that I fit it. Measuring beaker. This measuring beaker is made up of a glass, plastic. It is made up of metals like aluminium, and it is used to take out a fixed volume of liquid. Say now if you want milk, 200 ml only. Now in the measuring cylinder you can take at least 20 ml like that. But here if you have 200 ml, you have to dip it fully into 100 ml. You can't get 100 ml like that. If you want 200, you have to take 200 ml. Now you have measuring beakers for 50 ml, 100 ml, 200 ml, 500 ml, 1 liter. Okay, so these, and the capacity for measuring beaker is marked on it. If I, for example, I take 200 ml measuring beaker, so it will be written on it 200 ml. Okay. Next is my third vessel, Eureka can. You have seen this Eureka can in one or two places for gardening purposes and all those purposes. I have seen Eureka can. So this Eureka can, let me just draw Eureka can for you. It has a spout. So this spout where you can collect any excess water, and it is used for mainly gardening, to garden, or for you to pour water. Many purposes you have seen this Eureka can. So Eureka can is a glass or a polythene or a metal beaker which is with a side opening. This side opening is called as spout. As I told you, it's a spout. Thus the beaker can contain a volume of liquid up to the spout. Any excess of liquid overflows to the spout. Now till here only it will contain. If I go till here, everything will fall from the spout. Okay. Any excess of the liquid overflows through the spout. Now let us see how can we determine the density of irregular substances or irregular objects. Till now we saw what is density of a regular solid, and also the vessels for measuring the density or volume. Now for irregular solids. As I told you in vessels, I mentioned 3 vessels. One is measuring cylinder, measuring beaker, and Eureka can. In that I want now measuring cylinder. So to determine the density of irregular solids, first we can take its mass. mass can be taken through a physical balance, then its volume. So to find out density, two main things which are required are, first is mass and second one is volume. If these two are only there, you can find the density of any substance. So to find out the volume, we take the measuring cylinder. Okay, I draw the measuring cylinder. Okay, just draw it once again. Okay, so this measuring cylinder, I have markings from 0, 10, 20, 30, 40, 50, 60, 70, 80, 90 and 100. Okay, I take this as 90. Okay, yes, so I have the markings. So I pour 40 ml of water. So I told you water is not so, it has a meniscus, it won't be in a flat position. So it won't be in a flat position, so I take 40 ml of water in a measuring cylinder. I take an irregular solid, I took its mass. So let the mass be 120 grams. Okay, now I have to find out the volume. I tie it to a thread and dip it into the water. It should touch the ground. It should touch this bottom, okay? So, the level of water has risen to 60 ml now. So, it has risen. And now, we have to find out V2 minus V1 to find out the volume of this irregular solid. Now let me take the irregular solid as stone. I don't want to say irregular solid one more time. So let me take the irregular solid as a stone. So this is the final value. This is the initial value. Initial value is 40 ml and final value is 60 ml. So 60 ml minus 40 ml gives me 20 ml. 6 minus 4, it is 2. So my volume of the stone is 20 ml. So with that you can find out the density. Density is mass by volume. So 120 by gram. Yeah, one more you have to notice. Volume, you know, it is 1 ml is equals to 1 centimeter cube. So 20 ml is equals to 20 centimeter cube. 20 ml is equals to 20 centimeter cube. So here you will write 20 centimeter cube. Let me write the volume as 20 centimeter cube. If you write it as ml also it is correct. But if you take it as a gram, by 20 centimeter cube only, you can't take that ml. So there you have to take it. Then, so my answer will be 6 gram centimeter raised to minus 3. So the density of the stone is 6 gram centimeter raised to minus 3. So this is how you find out the density of irregular solids. Let me repeat it. So first you will find out the mass using the physical balance. So I found out it is 120 grams. Then I found out the volume using a measuring cylinder. I take the measuring cylinder. I pour 40 ml of water into it. Then I place a stone. So this is my initial level of water, 40 ml. And I place a stone, tie it to a thread, and this is called as displacement method. This method is called as displacement method, okay? So here the water level rises from 40 to 60. So V2 minus V1, so the final level of water minus the initial level of water, it is 60 minus 40 ml, it is 20 ml. You know that 1 ml is equals to 1 centimeter cube. So 20 ml is equals to 20 centimeter cube. So we got the mass, we got the volume, and we have to find out the density. 120 by 20, it is, make sure the units go correct. So it is 6 gram centimeter raised to minus 3. Okay. Next, if you like, share, subscribe it.